Hey ChemExcel, let's go over the Chatelier's principal quiz here. All right, there's going to be more questions than you were asked. Everyone got different questions on this, so just bear with me. All right, just make sure you are paying attention for all of them. I'll try to make it go quickly. Okay. All right, so first one here, we have the shift of adding HCl to our equilibrium system, okay? Gives us a hint. HCl produces H plus and Cl minus ions in solution. I don't see Cl minus anywhere in there, and it doesn't mention Cl minus, the chloride ion, reacting with anything here, so we're just going to casually ignore that because the system doesn't care it's there, all right? But it does care about that H plus because that is part of the system. So what we've done here is we've added a product which is going to make it shift towards the reactants. So that would be a reverse shift. All right. What color change would we see? Well, whatever color it started, it's shifting away from yellow and towards orange. So we would expect to see it get more orange. All right. For the concentration of the dichromate ion here, all right, dichromate is on the reactant side. We are shifting towards that. So it's going to increase, all right, and we are shifting away from the chromate, so the chromate would decrease, because if we shift away from it, it's using some of that up. And the initial impact on the rates, all right, because we added a product, the reverse reaction, all right, that's using it is going to speed up. So if our reverse reaction would speed up. The forward reaction is not immediately impacted because we didn't do anything to the reactants that the forward reaction is using. All right, one of the other shifts that you would have had show up somewhere in there is adding sodium acetate. Okay, and there's a hint in here too that the acetate ions react with the H+. Right, so we notice, first of all, sodium and acetate, those two ions, they're not in the system anywhere. All right, so we have not added a system component. But by adding something that reacts with H+ to form something else, this is going to remove the H+ from the system. All right, when we remove a system component, the reaction will shift towards it to try to replace some of that. So it's going to shift forward. All right, we would see it get more yellow as we are shifting towards the yellow color. The dichromate here, all right, would decrease because we are shifting away from the dichromate, so there would be less dichromate. The chromate, CrO4 here, would increase because if we are shifting towards it, then we are making more of it. The initial impact on the rates here. All right, this one's a little trickier. All right, we have removed a product. That's not going to directly impact the forward reaction because the forward reaction is not utilizing that substance at all. But the reverse reaction was using the H+. And the reverse reaction is now like, hang on a second, I was using that H+, right? And now these chromate ions are going to have a really hard time finding H+ ions to react with, all right? So the reverse would slow down. All right, another shift that you may have seen come up is adding water. All right, this one's a little bit more straightforward than the last slide, right? If we add water, right, we've added a reactant that will make it shift forward, right, towards the products. The color change, we would see it get more yellow. The concentration of chromate, that's going to increase because when we shift forward, we shift towards the chromate. And the dichromate would decrease because the dichromate is over here on the reactant side and we are shifting away from it. All right, this one had a couple of drop-down lists, right? So as removing a substance will what? Increase or decrease the rate because it increases or decreases the collisions. If you remove something, all right, you are definitely going to be decreasing a rate, okay? If you remove something, you can't expect a reaction to speed up. You just gave it less to work with, right? And the frequency of collisions is going to decrease, all right, because that other reactant is going to have a hard time finding the one that you just removed. So it's not going to collide very often. For how does adding a product affect the rate of the forward reaction? Well, we have reactants in equilibrium with products. The forward reaction uses reactants. So if you add a product, the forward reaction at that moment doesn't know that. It wasn't using the products. Adding a product would affect the rate of the reverse reaction, because the reverse reaction is like, oh, hey, more product. All right, let's get more frequent collisions. Let's speed up in the reverse direction. Okay. When we talk about rates, we do talk about the initial impact. Right? Obviously, as you saw with your equilibrium beakers extension there, they will even back out. Okay. And at the new equilibrium, your rates could be higher than at the old equilibrium if you added something. If you took something away, then your rates might be lower than they were at the old equilibrium. All right, but they will end up evening back out. So we talk here about just like that initial impact on the rates. All right, for this one, which way will the system shift if you increase the pressure by squishing the container? All right, what I saw on this one was that you guys are doing a great job identifying we want it to shift towards fewer particles, right? We have that rule, if you increase pressure, shift towards fewer gas particles in particular. All right, shift towards fewer gas particles. Sorry, my handwriting's really bad there. All right, and in this one, it looked like just identifying which side had fewer gas particles was more of the issue. All right, some of you were identifying that this side has fewer gas particles. You need to look at the coefficients on this one. This side has 3 gas particles, and this side has 4 gas particles. So it is the reactant side that has fewer gas particles, and so this would shift in reverse. All right, just a couple left here. All right, in this one, you saw what happened when heat was removed. Okay, we can see this one's still got some blue to it. All right, this one is more pink. All right, so we can see that removing heat made it more pink. So removing heat made it shift in the forward direction. All right, if heat was over here, let's rotate. All right, then removing it would make it shift reverse towards the heat. All right, so this is you can kind of guess and check on this one. Look at both of them, think about what would happen. All right, if heat's on the product side, then removing it would make this shift forwards, which is what we saw happen here. Okay, so putting it on the product side is the one that makes most sense. All right, and then this last one here, it's asking which of the following could have been unknown C. All right, so this is all the same concepts, just kind of thinking about it from the other perspective, okay? All right, in this case, the shift made it get lighter. So we're looking for something that would make it shift in reverse because it got lighter blue. Okay. All right, adding NH4OH, okay? All right, if we add this, that would make it shift forwards. So that's not what we're looking for. Okay. All right, if we add HCl that reacts with it, that would remove this from the system. That would make it shift in reverse. So that seems like a good answer choice. All right, adding something that reacts with this product over here. We don't want to remove that. If we remove a product, it would shift towards the products. That's not what we saw. Okay. And then that last one, if we add copper nitrate or copper 2 nitrate, which contains the Cu+2 ion in there, all right, then we are adding this. That would again make it shift forward, which is not what we're looking for. Okay. So adding something that would remove the NH4OH, the ammonium hydroxide, right, would be our best option here. Okay, and that is all I've got for you on this. Email me if you've got any questions. Right, if you've got questions, definitely make sure you've done the practice worksheets, taken the quiz, right? Everything before you go into that summative. All right, let me know what your questions are. Don't take the summative if you still have something you need to ask about.